So let's talk about schema matching and lexicon extension. I'm explaining this beautiful article from Temple University. And this model have three standard problems, let's say modules. So this is you're familiar with this supervised parsing as you do as usual. But sometimes you don't have some labels. You don't have enough labels. That's why you need to extend your training data. And then pattern learning incorporates new W and S into the lexicon of trained semantic parser. So the main essence of this article is just some kind of data augmentation. I mean, adding some training data to your very limited supervised data. So we reduce the task of learning a large-scale semantic parser to a combination of standard supervised algorithm, our matcher for finding corresponding between words and database symbols, and finally lex extender algorithm for integrating word database symbol matches into a semantic parsing lexicon. So we have a schema, we have some entities, relations, and also some categories and instances. Categories are one argument, predicates such as film. You can think about it like types. I always think about it like types. For example, the name of many films in your complex knowledge graph, billions of nodes, but you see many of them are in the category of films. So we can reduce this complex graph into some categories. Of course, they could have overlap as well. Something is also a film or is another thing. And in matching, we want to align them. We have a contextual schema and a database. So the textual schema matching task is to identify an alignment or a matching such that R of T and R of D, your text and your schema, they are a match. If and only if R of T can be used to refer to R of D in normal language usage. So the problem would be greatly simplified if you're matching M, where it is a one-to-one function, but in practice, most database relations can be inferred to in many ways by natural language. For example, when I say film actor, it can be referenced by the English verbs played, act, starred. So with morphological variants of them. In addition, many English verbs can refer to several different relations in freebase. For example, made can be either computer processor manufacturer or distilled spirits producer or many other things. But our matcher algorithm for textual schema matching handles this by producing a confidence score for every possible pair, which downstream applications can then use to reason about the possible alignments. So matcher only determine that the actress aligns with the film actor or not. It cannot produce an alignment between actress and a join of film actor and gender. So it matches simple things. It uses a web search engine to issue queries for a database relation. And there are some patterns, pattern-based match selection. For example, you can use these templates and, for example, found in 1980, some relations in E, so it ends up with ED. A measure similar to pointwise. The thing that I enjoyed this article is this pointwise mutual information. You know, I've talked about mutual information in my playlist for information theory of deep learning. And here we have pointwise mutual information. So so C here indicates the sum. This C indicates the sum of all counts of a particular pattern. The pattern is P, for example. This P is the pattern. It's sum of all counts of the particular pattern. Database relation, this is database relation, and textual relation. And so this says that what is the mutual information between database relation and text relation, which is really interesting. Oh, by the way, you can use open information extraction of Stanford. It's an open source. This developed by great people like Christopher D. Manning, the founder of Glove, and many interesting things. You can download it and use it. Just run it by Java, and then pointwise mutual information. When people say they use OpenIE, it means it can often provide a large set of extracted tuples for a given R of text. For example, when you say, what are the neighborhoods in New York City? How many countries use the rupee? You can write it like this. So the logical form of that is this. So after learning, it understands the logical form. Oh, this is the old Persian inscription in Persepolis in Shiraz inside Iran. So we can also learn these old languages. Of course, Iraq was part of Iran 300 years ago, 200 years ago. And they had a common language. So now we can understand, we can use dependency parsing, semantic parsing, and many computational linguistic things for these things. So we can discover what those very old Iranians were thinking about.